Okay, welcome to 8.5 part 2. Let's continue with example 5. So in this one, let's set up our fractions. We notice we'll have one of our denominators be a. We have a over x plus, and then we have an x squared plus 1. And then we're going to have another x squared plus 1. This will be the squared version of it. So like we said earlier in part 1, if it's a irreducible quadratic, we're going to put a linear numerator on top. So that would be bx plus c. And then this one will be dx plus e. Okay, so to get our common denominator, which will be x times x squared plus 1, that quantity squared. For this fraction, we would multiply by x squared plus 1 squared. And then this middle one, we would multiply by x and x squared plus 1. And then this last one, we would only multiply by x. Okay. So, let's expand on the x squared plus 1, because we will need that. So the a will have to distribute to, that'll be x to the fourth plus 2x squared plus 1. And then for the bx plus c, that's going to distribute to, let's do distributing of the x to that other one. That would be x cubed plus x. And then the x here we could distribute in, we would get dx squared plus ex. Okay, so we have to distribute the a, and then we would have to FOIL this out. Okay, so we distribute the a, we get a x to the fourth plus 2a x squared plus a. And then here, FOIL this out, bx times x cubed, that would be bx to the fourth. Bx times x is bx squared plus cx cubed plus cx. And then we have the plus dx squared plus dx. Okay. Now notice we don't have anything in the numerator, so it's like we're adding to 0. Right? So we have, let's group together our x to the fourths. We have ax to the fourth plus bx to the fourth. Okay, so now that's going to equal 0. We have a cx cubed. Any other x cubes? No. So we have cx cubed equals 0. X squared, so we have a 2a x squared plus a bx squared. We don't have a cx squared, we have a dx squared plus dx squared. That's equal to 0. Any x terms? We have a cx term. Right, just a plain cx term. Oh no, we have an ex term also. So cx plus ex. That would be 0. And then for the constant term is really, I said 0 earlier, but it's really a 1 here, right? It's like a 1 dx. So your constant term, if you have any constant terms, which we should, would be equal to 1. Okay, so constant term would be the a, right? That's the only one with no x on it. Right, so a would equal 1. Okay, so this kind of makes it a little easy for us. We know that here, based off of this, that c has to equal 0. And if c is equal 0 here, then e has to be equal to 0 here. So e is equal to 0. We know that a is equal to 1. Is that enough to help solve the rest? Well, here we know that a plus b equals 0. So if a is 1, b has to be negative 1. And then d, what else do we have here? We can solve for d with this equation. So we have 2 times a, which is 1, 2 times 1, plus b is negative 1, plus d equals 0. So 2 minus 1 is 1. 1 plus d equals 0. So d equals negative 1. Okay. Alright, so let's do that then. We know that a is 1. We have a bx plus c, so negative x plus 0. And then we have a dx plus c, so another negative x plus 0. Okay. So this is what it should look like then. So far, we have 1 over x plus negative x over x squared plus 1 plus another negative x over x squared plus 1 all squared. Okay, so what we could do is set up a little u substitution here. Looks like we have everything in place. We just maybe move the minuses around a little bit. So we have we have 1 over x minus x over x squared plus 1 minus x over x squared plus 1 squared. Okay, so now if we integrate this, this will just be ln of x. Now here we're expecting a 2x here, we don't have it, so it's going to be 1/2. Okay, so we have ln of x minus 1/2 ln of x squared plus 1. And then this one we could just integrate normally, so this would be, we're expecting the 1/2 there, so that would be, and then we got that negative 2, so we plus 1/2 of x squared plus 1 to negative 1 plus k. Now just rewrite that if you want to. We have ln of x minus 1/2 ln of x squared plus 1 plus 1 over 2 x squared plus 1 plus k. And that will be the final answer for that one. Okay. Alright. Let's take a look at another one of these. Let's find a, b, and c in the partial fraction expansion. Okay, so let's just take a look at another way of solving this problem. So another, just a smaller technique we could do is, like for example, if we picked one of these denominators and we multiplied by that denominator left and right, it could bring us towards getting our A, B's, and C's a little bit quicker. It's all about the same, but if you want a slightly different technique, so let me show you guys that one. Okay, so for example, in this one, if we multiply both sides and you pick one of the denominators, either x minus 1, x minus 2, x minus 3. I'm going to pick x minus 1. Okay, so if I multiply both sides by x minus 1, and I multiply by x minus 1 on the right, x minus 1 on the left, so that allows me to cancel here. And then when I distribute the x minus 1 here, so let me show you what happens. So we have x squared plus 1 over x minus 2 times x minus 3 equals, well, when I distribute the x minus 1 to a over x minus 1, the x minus 1s will cancel, and then we would have b x minus 1 over x minus 2 plus c x minus 1 over x minus 3. Okay, so now you think to yourself, okay, if I were to plug in x equals 1, right, like if you plug in x equals 1, look what happens here on these fractions. Well, when you plug in 1 here and 1 here, those turn to 0. Right? So all you're left with a. And if you plug the 1 in here on the left, that gives you what a is. Okay, so it's just a technique of finding, your a, b, and your c, slightly different fashion. It kind of avoids the system of equations route. Okay, so if we plug in 1, we get 0 and 0, and we get the a equals 1 squared plus 1 over 1 minus 2 times 1 minus 3, which gives us what? On the top it gives us 2, bottom it gives us negative 1 times negative 2, which gives us 2 over positive 2, which gives us 1. So we know that a is equal to 1. Okay. So now if we start off, let's say from the beginning again, we multiply both sides by x minus 2. Right? What happens then? Well, if we multiply x minus 2, we would get x minus 2. Well, the x minus 2 and the x minus 2 on the left would cancel. So we would be ending up with x squared plus 1 over x minus 1 times x minus 3 equals 2 times x minus 2 over x minus 1. The x minus 2 would cancel with the one with the b, so b would be left alone. And then this should be an a here. And then the one with the c would have c times x minus 2 over x minus 3. And now let's plug in x equals 2. Right, so if x equals 2, these two go to 0. Right? 2 minus 2 is 0. So 0 times anything is 0. So we're just left with the b. So b equals, and then plug 2 in there. 2 squared plus 1 over 2 minus 1, and then 2 minus 3. 2 squared, 4 plus 1 is 5. 2 minus 1 is 1. 2 minus 3 is negative 1. That means we have 5 over negative 1, which is negative 5. So b equals negative 5. Okay, and then we could do a similar thing with the c. Multiply both sides by x minus 3. So we'll have a final statement of, and then we're going to plug in 3. We'll have 3 squared plus 1 over 3 minus 1 times 3 minus 2. This will be for the c. So 3 squared is 9 plus 1 is 10. 3 minus 1 is 2. 3 minus 2 is 1. So we got 2 times 1. And 10 over 2. So c would equal 5. Okay, so that'll give us the 3 ways of, well, another way to get our A, our B, and our C. And that's all they want in this one. Find A, B, and C in the partial fraction expansion. Okay, so let's continue to the next problem. So in some cases, what we could do is to differentiate, and then we can try to figure out what A, B, and C are. Okay, first we're going to clear the fractions. Okay, so that means we're going to multiply everything by the common denominator, which will be x plus 1 cubed. So multiply by x plus 1 cubed, both sides. Okay, so that leaves us with x minus 1 on the left, x plus 1 cubed, and the x plus 1 will cancel. You're left with a squared there, so a times x plus 1 squared plus b. Now the x plus 1 squared will cancel with 2 of them. We're left with b times x plus 1. And then all of them will cancel with the one under the c, so we're just left with c. Okay, so we cleared the fractions. Now if we plug in negative 1, right, let's do that. Let's plug in negative 1. x equals -1. So we got -1 minus 1, that's -2. And a -1 plus 1, that's 0. So that's 0. -1 plus 1, that's 0. So we have 0 plus 0. So we got c equals -2. So c equals -2. Okay, next, if we take our equation that we ended up with, the x minus 1 equals a x plus 1 squared plus b x plus 1. And we take the derivative of this. If we take the derivative of x minus 1, we just get 1. If we take the derivative here, we get 2 times, right, bring that 2 in front, 2a of x plus 1, and drop the power on the 2, plus, and then we take the derivative here, we get plus b, and derivative of c is 0. Okay, and now we end up with this equation. If we plug in -1 here, we could end up with b. Okay, so plug in x equals -1. So we got 1 equals, plugging in -1 here gets us 0. 0 times 2a is 0. So we get b equals 1. Now, if we take the derivative of this equation, okay, so now take derivative, so what do we get? We get 0 equals just 2a, right? And then the b goes to 0. And now we can solve for a. Okay, so 2a equals 0, so a equals 0. Okay, so that means according to our original problem, if a is 0, that's 0, and then b was 1, b is 1, and then c is -2. Okay, and that gives us a way to figure out a, b, and c. Okay, let's take a look at another problem. This is actually example 6, but now we're going to use a slightly different technique. So what we could do is to clear the fractions. So first thing, let's clear the fractions. So we multiply everything by the common denominator. Right? So we multiply everything by x minus 1 times x minus 2 times x minus 3. So we're left with x squared plus 1 on the left. And then if we multiply here by x minus 1, x minus 2, x minus 3, we would get the x minus 1s to cancel, and a would be stuck with x minus 2 times x minus 3. For the b, the x minus 2's would cancel, and that would be stuck with x minus 1 times x minus 3. And then the c, the x minus 3 would cancel, and then c would be left with x minus 1 times x minus 2. And now you could just, looking at the factors, you could start plugging in numbers. You could plug in numbers to narrow your variables down to get a, b, and c. Okay, like for example, we could plug in x equals 1. right? So let's say x equals 1. Now, if x equals 1, I have on the left 1 squared plus 1 equals a, and then 1 minus 2, and then 1 minus 3 plus b, 1 minus 1, 1 minus 3 plus c, 1 minus 1, and 1 minus 2. Okay, so the nice part about this, you guys would recognize right off the bat, well, whenever you get the 1 minus 1 and you get the 0, well, that takes care of that term. And that takes care of that term there, the 1 minus 1. Okay, so now we could focus in on what's left, right? 1 squared plus 1, that's 2. And then we have a, 1 minus 2 is negative 1. 1 minus 3 is negative 2. So we end up with 2 equals, negative 2 times negative 1 is positive 2, so 2a divided by 2. So that means a would equal 1. Okay, you could do a similar thing with getting the others. For example, we could do say x equals 2. Plug in x equals 2. So that means we have 2 squared plus 1 equals a 2 minus 2 times 2 minus 3 plus b 2 minus 1 times 2 minus 3 plus c 2 minus 1 times 2 minus 2. Now, everywhere you see a 2 minus 2, you know that term is gone. You got a 0. Right? That's gone. That's gone. So now let's see what's left. So 2 squared 4 plus 1 is 5. And then the b, we have 2 minus 1 is 1. And then 2 minus 3 is negative 1. So we have 5 equals negative b. And so b equals negative 5. Okay, and then let's do the only other one that makes sense here would be x equals 3. Let's do x equals 3. X equals 3. So 3 squared plus 1 equals a of 3 minus 2 and 3 minus 3 plus b of 3 minus 1 and then 3 minus 3 plus c of 3 minus 1 and then 3 minus 2. Okay, so you have anywhere you see the 3 minus 3, you get the 0. 3 minus 3 here, you get the 0, so that's gone. So now you're left with 3 squared is 9 plus 1 is 10. C, 3 minus 1 is 2. 3 minus 2 is 1. So we have here 10 equals 2c divided by 2. So c equals 5. So you start to see a little different technique. If the system of equations sometimes it gets a little complicated, you could do this workaround to get your A, B, and C. Okay? Any questions, just write me an email or bring it up during the lecture. I'll see you guys soon. Have a great day. Have a great night. See you later.